squared over over 2g is canceled because there's only one velocity that's moving in this case, or it's only one, like the first velocity, so we're counting on, or
No, I mean, still, okay, there is velocity, but as you approach this point, exactly at the point where it meets this tube, it will be, it's like having a vehicle and this is the wall and you have the vehicle come with a speed, but at the moment that it hits, you can assume it's instantaneously zero. I know it's a bad example. I have a better example, Brad. You're like,
that's a pretty good one. That's a good example.
The what?
Would the gammas cancel out?
No, well, we can cancel it, we cannot cancel the gamma because here is not gamma. But what we can cancel is what?
Rho.
The rho. So what I will do, yeah, that's a good observation. Rho over g, I can substitute now, that's okay. And now for the simplicity, we can cancel g. So you have v1 squared over 2 equals p2 minus p1 divided by rho. Actually, you know what? Now that I'm thinking, it was a bad idea.
Oh.
It was a bad idea. That now, you know, I know the solution. I see that they do that, but I don't like how they do it. So I will not do it. I will explain you why. Actually, I want to make your life easier now. That's why I'm going to keep it. Let's keep the gamma. Okay. So that being said, your V1 squared is equal to 2g P2 over gamma minus P1 over gamma, which means your V1 is the square root of 2g P2 over gamma minus P1 over gamma. I just wrote it as a formula for the time being, but I didn't do any crazy calculations, as you can tell. Well, I hope you don't find me crazy.
Is this because we're given gamma in this?
No, that's not the reason. I'll tell you why I kept it. Actually, they didn't even give us the gamma. Now the question is why I kept it as P over gamma and I didn't substitute back. Finish that and I will explain. That goes back to what we said last week. And I don't know if you remember, I think someone from the back, I think you said that, Michael, I think so. It has to do a little bit with the units.
Oh.
My question was, what is the unit of P over gamma?
Oh,
as a
it's
quantity?
meters. It's
It's
meters.
in meters. It's the unit of length. And why is that? Just to refresh your memory, because since elevation we know is in meters or centimeters, unit of length, this needs to be on unit of length also, and this one needs to be in unit of length. So we're not looking now the pressure as kilopascal pascal, which is important, but now we look the pressure more in terms of the length per unit weight of the water. And why this is easier? Because now I know how much is my pressure head at location number 2 in terms of length. How much is the pressure head at number 2 in terms of length?
0.
Huh? 35, right? Is the height of that cube. Okay? Now 35 centimeters, I need to convert it to meters because my G is meters, okay? So 0.35 meters minus, how much is the pressure head at 0.26?
Oh. Okay. I see that.
Okay? So if you do that, you're gonna end up getting 1.33 meters per second.
Oh, and that's because P2 or P over gamma. That's since that is since that's the pressure head. That's basically the pressure meters. Makes a lot of sense.
You see the difference between the two tubes, the difference between those two tubes, it will give us the velocity in the pipe at that specific location though. So I know that the velocity here of that fluid, of the water, is 1.33 meters per second in the middle of the pipe. Does it make sense? Now, simple case, because I like also to tell you simple things. So let's say, you're in the garden, here is your house, blah, blah, blah. And some of you have here on outside, there is a little faucet, and you have a hose, right, to water your garden, right? Okay? Now, if you